Hi, our medical device is the SmartPlate. The SmartPlate is used in conjunction with the A-plate or the quad plate made by Orthofix, or more importantly, Dr. Peter Stevens. So what is the A-plate? It's a guided growth system that basically it is inserted into a convex side of a child with an angular deformity, such as, say, knock knees or bow-leggedness. And what this does is it stunts the growth on the convex side and allows the defected side to catch up. And then once the defected side is caught up, the device can then be removed, and the child can then go on with their lives once their angular deformity is fixed. So the problem or pain point with this current device is that methods of measuring progress while using guided bone growth systems require the patient to return to the hospital and receive x-rays, which can both be inconvenient for the patient and expensive, and makes more frequent measurements less feasible. So our SmartPlate device is a handheld device that we have a sensor on this outside, and then the sensor moves along this opening. And what this does is it measures the movement of the screws as the screws diverge. And then with all this data is then exported to a physician GUI, and then the physician can then track the real-time measurement of the growth of the bone. Okay, so here's an exploited view of our device, and so when we actually collapse this view, you see that we have a servo motor that attaches to a rack and pinion gear, and this is all powered by an Arduino Uno, so that when it's all enclosed, the servo motor can then power this plate to slide where the sensor is attached at that little opening. And so the idea is that we take two magnets, we place it into the screws, and then the distal end of the screws are then tracked, or the distal end of the magnets are then tracked with the sensors, so that we can actually measure the distance between the magnetic fluxes, and then approximate the distance between these screws as they diverge, and furthermore approximate the growth throughout the procedure. And then once it's actually powered, you see how the rack and pinion gear slides across. That was, as I mentioned, powered by the Arduino Uno. And so then a brief demo of how this device is actually used is that the patient or caregiver will take the handheld device and they'll hold it up to their leg. When they hold it up to their leg, they will then power on the device so that the sensor slides along, and then we'll actually measure the distance between these magnets, or the distance between the screws. The data is then processed to approximate the distance between them. It is then sent to the physician so that the physician can load the data into their GUI or their app, and then they are able to see a real-time timestamp the distance between the measurements, as well as the growth that has occurred between the last measurement as well as the overall procedure.